Okay, an angle bisector of a triangle divides the opposite side of the triangle into segments 6 centimeters and 4 centimeters. I'm going to sketch this out. Okay, you've got some angle bisector, and oops, let's say it looks like that. Okay, and we know then that this is equal to that. Angle marks, that is equal to that. And if the opposite sides are 6 and 4, we can say, okay, so we've got, oops, 6 centimeters and 4 centimeters. Okay, now the second side, a second side of the triangle is 7.4 centimeters. So it could either be that it is 7.4 centimeters here, and this is x, and we can set up a proportion because the sides will be proportionate to each other. Okay, so we can say 4 is to 7.4 as 6 is to x. Okay, that's one way of it happening. Or the other thing that could be happening is that instead of the 7.4 centimeters matching with the side that's 4, that 7.4 centimeters could be matching with the side that's 6. And this could be x. So let's set that proportion up over here on the side separately. So you've got 4 is to x as 6 is to 7.4. Okay? And this is where you can use your famous picnic table method to say this times this divided by that. But I'm going to write it out the way that I prefer, is to just multiply the diagonals. This times this equals this times that. And we get 4x is equal to, let's see, 7.4 times 6, 44.4. And when we divide both sides by 4, we get x is equal to 11.1. Or it could have been this way over on this side, and these diagonals multiply. So you get 6x equals 4 times 7.4, 29.6. And then when you divide both sides by 6, you get 4.9333333, which they're asking us to round the answers to the nearest tenth of a centimeter, so approximately 4.9. Okay, so that's the idea, that this 7.4 side could have matched with this longer of the two sides that when it split off, or with the shorter sides. You got to set it up as both. So then we have x could either be 11.1 or it could be 4.9. And where is that? That's answer C.